Hello, fellow thrill seekers. Welcome to Adventures with Taiki. I'm your fearless leader, Michelle Jones, Reiki practitioner, adventurist, and boundary expander. I'm curious about what's beyond the horizon, behind the locked door, and I have questions that most people are afraid to ask. Will you set out on this quest to soothe some curiosities with me? Hit that subscribe button and buckle up as we take an epic quest into the physical and metaphysical realms of wonder and intrigue in search of thrills and answers to some of these questions. Welcome to another Adventures with Taiki. Today we have a special guest with us. We have Jennifer Rogers from Pariah, Meraki, and we are at the National Weather Service Museum in Norman, Oklahoma, and we are asking one of the guides if he would give us a guided tour, because he knows more about this stuff than we do, so we'd like to get his information and his intake on this. But we just want to show you around the museum, show you what's here, and while he's checking with that, we're just going to show you the little area up here for their gift center, show you what's available. All right, check it out. Brush robot. Okay. What does that do? A robot that scuttles along on a brush. It's powered by rapid vibrations from its motor. Brush robot that will sweep you away. Jennifer, what do we do with that? Look at all these old parts, tubes and whatnot. Isn't that funny? What is this? A character kit. Build it yourself. Oh, how fun. He's got kind of wompy wheels. I wonder if all this stuff works. Like, are these the black boxes or... See, this is why I like them to take me around so they can tell me what it is.
Oh, here's I know what this is.
That's an ice scraper. Ooh.
Here's that. Check that out.
Twister smashes Lubbock. 20 dead, hundreds injured. Wow. Look at Google technology back then. 33 rule. If the time between the flash of lightning and the sound of thunder is less than 30 seconds, take shelter for 30 minutes. After the last thunder is heard, decrease your exposure when thunder roars. Go indoors. I did not know this. What is this? King of cameras. Oh, that's a camera? Oh, there's the lens right there. It took that picture of that lightning. Look at that. Wow. Kind of thinking had to come up with that. Please find a staff member for a demonstration. Oh, I can't wait to see that. Oh, this is a cockpit. One person at a time on the cockpit.
Look here. Look at the hail damage on the wing.
Oh, wow. Air Force F-100 aircraft. That's insane.
So when people wonder why there's no flying
in bad weather,
that
would be a good reason. One person at a time on the cockpit, one person on the scaffolding, one person on the steps.
The empowering showcases more of the lighting, and it's a showcase. Once it's more randomized, it's more. You did that overall in the storm, and then it just starts going away.
Together morning we have lighting.
So Stephen is with the National Weather Service Museum. He's going to show us around. Thank you, Stephen.
Yeah. So we can start out over here. This is our green screen, and the green screen is what the TV meteorologists stand in front of when they give their weather forecast. And so how it works is it replaces everything that's green in the background with a weather map or footage of what's going on, so you can stand in front of it and talk about the weather. So just like at the demonstration, I could get in front of it here and like point out some rotation with this tornado, for example. So,
wow.
If you're interested, you can also stand in front of it and try to give a weather forecast.
So today out here in the plains, it's going to be really hot and really humid. How fun. You want to try?
I'm good.
How fun is that?
So yeah, people, when they're giving their forecast, they'll have a screen that's like behind the camera they can look at so they can know where to point and what's showing. They don't like have a teleprompter or anything because the weather changes enough that they want to just like have an idea of what to say, but then be ready to change that if something comes up.
Yeah, that's where
Awesome.
the ad-libbing would be where I would. Is this a wind tunnel here?
Yeah, so this is a thing where for $3, if you go in there, it'll produce 78 mile an hour winds, which is as strong as a weak tornado. So you just kind of feel what that would be like if the wind was blowing at you.
Oh, we got to try that.
I say we do that when we leave.
Okay.
For our hairs.
So our hair is fine? Okay.
Yeah.
Well, I wouldn't care either way, but okay. We'll wait until we leave for that way.
You can see that ponytail would just.
The Wizard of Oz.
It's mostly just like a kid's little photo booth.
Oh, cute.
Cool.
So yeah, because the Wizard of Oz teaches you a tornado, so it's just like a fun way to talk about how weather affects cinema and other industries as well.
Absolutely.
And this section is all about radar. And so here we have a display of a weather radar from the 1950s. And so radar started a little earlier in World War II to detect enemy aircraft. And they soon found that weather systems could impact their radar returns, and so that they could decide to fine-tune the radars to detect the weather more effectively. And found that it was a useful way to figure out where storms were at a distance. And so radar works by sending out a beam of radio energy, so radio waves like for a radio station, for example, and it'll bounce off of the rain or snow and come back, and how much gets bounced back is how strong the rain or the snow is.
Oh.
Here we have something called a opdar, which is a little radar that will detect people. So if I turn it off, you'll see this yellow line bounce up and down on this display, and if you move around, you can see the yellow line adjust as it's detecting you going to different places.
So what is this used for?
So this is honestly just kind of like a fun display showing the technology of radar. It doesn't have a super practical use, but something like this could detect maybe a vehicle or something like that. Like the police, for example, have their radar guns to detect the cars, like how fast they're going and stuff like that.
And it's called Bobdar?
Yeah, so I think it's just a funny name, like detect a person named Bob, so Bob knows.
While they're dodging and bobbing. That's fun.
Yeah, so then in this corner, we just have, well, here are some old computer printouts of radar data from back in
Oh, wow.
the 1970s. And so if you were trying to analyze it, you'd have to like draw a pencil and show the areas of higher values that might indicate heavy rainfall, for example. And here we just show the more modern radar picture. So where now we just have it all.
I'm old enough to remember technology like this. I had a job that printed out pages and pages of information like this. I don't remember what job that was. But yeah, I think it was when I was out on the Schriever Air Force Base.
Interesting. And yeah, so here we have, this is an old Doppler radar. And so Doppler radar works by, so it detects not just the intensity, but also the speed of the precipitation. So if you know about the Doppler effect of like a train being like high pitch coming towards you and though going away and stuff, the same thing happens with the radio signals where the rain is moving towards you, it'll be at a higher frequency, and if it's going away, it'll be a lower frequency.
Oh.
So they have like a fancy computer that can detect that change and figure out how stuff's moving. And that's how you can detect like rotation that could lead to a tornado forming, for example.
Wow. I did not know that, did you?
Yeah, so this radar was at the Max Westheimer Airport, which is just up the road.
So they needed all this equipment to detect whether a storm was coming or going.
Yeah.
Wow.
So this is from the 1960s, so things were a lot more manual back then. They didn't have as good computers. And this was the whole like control in it, so you could adjust like the angle like up and down or horizontally that would point that. So there's a lot of things going on with this device. And I mean, now that can only run just with like a laptop or a computer, so it's a lot easier. And they just have certain preset patterns that they pick for like scanning angles and whatnot.
So have you ever been able to speak to someone who once ran one of these and then see what technology is today to get their thoughts of just like, wow, this is leaps and bounds from what I used to do back in the day?
So sadly, I haven't spoken to anyone who's operated this particular unit, but I did have an internship at the Radar Operations Center, and my boss went to OU around like 1980 and studied meteorology, and then worked at the same place for like 30 or 40 years. And so he was able to talk about just the different technological changes that have come in that time, and different things that they tried and didn't work and all that. So that was definitely interesting to hear him talk about.
And then what you'll see change from where you are
Where you're
operating
starting,
today
yeah.
to, you know, just even 10 years from now with as fast as technology is.
Yeah, it's definitely exciting to see what will come up in the future.
Yeah, my youngest son went to meteorology school, so he knows all this stuff. And he'll call me and tell me. One time I called him when we had a microburst come. You remember when the skirting blew out from under the house? I was on the phone with him. He's like, "Mom, it's just strong line front line winds or whatever they're called, straight line winds or whatever." And I'm like, I've lived in Kansas for 25 years. Don't tell me this is the same as everything else. He couldn't convince me as the whole underside of my house went out from underneath of me. It was scary. It was scary. What is this piece of equipment?
Yeah, this is a power transmitter for the radar. So this basically generates the radio signal that then gets sent out.
Wow.
To scan.
Look at the size of that vacuum tube in there.
Yeah, so that's from like 1957 or so, I believe.
And that just goes out on a regular, like, radio antenna?
Yeah, so, well, the signal gets sent out in the radar dish, which we have a picture of
Oh, okay.
this right here. So we focus the beam like coming out.
So like the bottom of this here.
Yeah. And then what we have here are some phased array panels, and phased array is a new radar technology that is in development that could send out multiple radar beams at once. So each of these panel could send out its own beam, and what that could do is it could scan a larger area at a time. Because right now a radar has to spin around at several different angles, elevation angles, like based on how much above the horizon it's looking to get a 3D picture of a storm. And this way you could just scan one whole area, then move to another whole area, then
Oh, kind of like LiDAR.
It's a little bit like that, yeah.
Yeah.
It would be a lot faster. So
Interesting.
yeah, we also have a few pictures of radar trucks, and so a lot of the research, they'll put smaller radars on trucks and then get up closer to a tornado or a severe thunderstorm to see how that storm is developing at a faster time scale and at a higher resolution.
Well, now when you see one of those trucks, Jennifer, you'll know what they're doing.
I've never even seen one, so now I have to be on the look for one.
Have you all been to the National Weather Center in the south side of Norman?
No.
Yeah, you should do a tour of that. They might take you into the vehicle bay. You can see some of those trucks.
Oh, that would be
They have
cool.
other things as well that they can show you there.
Yeah. And what's happening over here?
So on the top here, we just have a live radar display. So you can tell there's not a whole lot going on right now. Like this is the reflectivity or the intensity. So it's just, I think this is honestly just picking up like some dust or something like that. There's hardly been any rain today. This is velocity. So the green means it's going towards the radar, the red is away. So your end is going that way basically. And then this is something called differential reflectivity, which is basically just the shape of the things it's picking up. So high positive values means it's more horizontal, and then negative values are more vertical. And so this is useful for rain, and that big raindrops are like hamburger bun shape, kind of like that.
Oh.
So positive values mean that you're getting big raindrops. But in this situation where you're getting super high values, I think it's just bouncing off the ground. And that's kind of what you're seeing.
Oh. Interesting.
Yeah, and this is the correlation coefficient, which is just how similar or different are your radar returns. And these low values mean you're just picking up like probably ground clutter sorts of things. And like pure rain or pure snow would be a high value. And then the mix of rain and snow or mix of rain and hail would be like a moderately low value, and a very low value like that is just debris or other stuff like that.
So it even picks up what's just in the air around us as...
Look, well, it says right here, rain, snow, ice, birds, or bugs.
Or bugs. That's insane.
Yeah, so sometimes they can detect if there's a big swarm of bugs, like a bird migration or stuff like that.
Interesting. That's very interesting. So can you tell us about this camera?
Yeah, so this camera was so this was originally a military camera used to take video of explosions, and then it was going to be scrapped. So the Stone Chaser Tim Samaras purchased it and converted it over from film to digital and used it to take video of light in. And so basically the light would come in here, then there would be a mirror here that would be powered by a compressed gas that would spin the mirror around, and it would reflect light onto all these different detectors, and you could get a very high frame rate that way because each detector to be working kind of at the same time to process that one image. And so sadly Kim Samaras passed away in the 2013 El Reno tornado where he was assisting it.
I heard about that.
Yeah, passed like south and he wasn't expecting it, and so he and the two people he was with sadly lost their lives. And
Yes, I heard about that.
yeah, so it's even like a memorial to him where that happened. But yeah, his camera was not with him that day, and so that's how we're still able to have it here at the museum.
Yeah, I remember when that happened. My son, because he went to meteorology school, so him and his dad went to weather chasing school as well. So I did hear about that. And can you tell us about this here?
Yeah, so this is a E-28 aircraft. We have another one on the back that I can show you later. And so we have this as a flight simulator. So just because aviation and weather are related, like the pilots always have to be aware of the weather. And so if you want, you can go up in it and try to fly the plane.
Okay. All right.
You don't want a front view of
No,
an
I want you to. You can come maybe stand just right here and film me. We got to try it, Jennifer. We're here. Okay. All right. So how do we fly the plane?
Yeah, so this right there is your joystick, and you'll use that for steering.
Okay.
So side to side, and then pull it towards you to take off. And then this is your throttle, and so that's the speed. And so to take off, you'll want to move the throttle forward.
Okay.
And so I think your brake might be on. So there's a trigger on the front of the joystick, like that. Now let go of that, and then now you'll start to accelerate.
I better stay on the runway first, though.
Yeah, it wants to steer you to the left, so you just have to kind of account for that. And if you go into the grass, it's not a big deal. Your plane will still handle it. And then I think you might want to keep going a little faster. Bachi.
How do you do that fast?
Actually, she's crashed.
I've already crashed.
So it will reset after you crash.
Okay, so let's get a little bit. So we have our throttle, and now this is how we're going to steer. Let's turn this off for just a second, and then what else do we need?
So this is your propeller speed. You just keep that on full. This is your flaps. You can just keep those up, so you can just leave those as they are.
So just do again what I did and crash again.
So wait a little bit to pull the joystick towards you until you're going a little faster, and then you'll take off more smoothly.
Okay.
That's the one.
So do you have this nailed? Have you done it enough to nail it?
I'd say I'm familiar with it. Yeah.
Okay, we'll get a video of you doing it too, so you can show us how to do it properly after I crash us. Okay? Is that fine? Okay, so we're gonna give it throttle,
Yeah.
and then we're gonna come back.
So don't pull it towards you yet. Just leave it and just do side to side. And I think your brake is on.
Oh, it resets as us.
Yeah.
Okay.
So I'll tell you when to pull it.
Oh, boy, it really wants to pull you.
Yeah.
Oh my goodness.
So imagine wind with that.
Yeah, no doubt.
And so now you're going pretty fast. You can pull it towards And be careful not to steer it too violently side to side, or you'll.
I don't know. Yeah.
But yeah, so it is a challenging the steering part of it.
Oh. Jennifer, you do not
Who's
want to
looking
fly on
fly
Jones
with
Air.
Michelle?
Just do not fly on Jones Air. I'll tell you that right now. This is not recommended. All right, Stephen, we're going to let you try. Show us how to do it.
That's weird.
You really crushed
I
it.
really crashed it. Look, I have to reset the whole thing. That was actually kind of fun, though. Scary, but fun.
He said, oh.
Yeah, we're not going to get in the airplane with her anytime soon.
I'll put that down here so that you guys have space here.
All right,
Kind of
then.
tight.
I imagine if my sons were here, they would have the most fun trying to figure this all out. When you're bored. I don't blame you. I think I'd be in here trying to not to. How many times do I have to crash before I can take off successfully? It'll be like that lollipop or that Tootsie Pop commercial.
Yeah.
How many licks does it take to get to the center of the Tootsie Pop? How many times does Michelle have to take off before she doesn't crash? But this has got to be easier for the younger generation too, playing video games all the time. You know, they're more used to joystick stuff than we are. Oh yeah, see, I've never even done that. Yeah, the straight part is the hard part. Let's take out the tower. See, I don't feel so bad now.
Next time you're on a flight and they're in the grass, don't worry.
Don't worry. And it is hard to see over that dash, isn't it? Yeah, see, I couldn't process that many things at one time. I better slow down. I better lower my flaps. I better this. I better that. Oh, I forgot my landing
I'm looking
gear.
at the designs and the grass out there in the field.
I do that too.
It looks like a person flexing to me.
It does, doesn't it?
Got a nice six-pack going on.
Just take the road. Oh no, this house is fine. Stephen, you made my day. You made my day. Yes, that was so much fun.
There's a plane in their backyard now.
Thank you for humoring us.
That was great.
Well, I think a lot of people would want to know that. And what are the drones here now? What are these for?
Have been started to be used in the past decade or so for weather forecasting, or mostly for research at this point, where they'll just take drones out and send them up and down over the course of about a few hours, just collecting data.
And so they have radar and wind speed detectors. What kind of data are they collecting?
So usually things like temperature and air pressure and wind speed and humidity. They don't usually have radars on them, but I think you could probably put a small one on there if you wanted. And right now, most like upper air data is done with weather balloons, but there's some hope that maybe drones could replace that in the future because they're reusable, whereas the balloons just go up and then they pop, and then the instrument package is hard to find sometimes. But we're still a little ways off before that becomes a commonplace thing, so it's more just experimental stuff.
But how fun would that be to have that job? Just to go out and chase the weather and throw up your drone? You might be good at that. It would.
Yeah, this is a Euro by C8, so you're trying to out.
Oh, should we?
Yeah.
Should we? Jennifer's like, yeah, let's see what we do on this one. Okay, Jennifer, here we go. I have never, and it has the two, so even on Rainbow Road, like I used to do like this with the whole controller, you know what I'm talking about on Rainbow Road. So this will be really good. I can't fly and look around at the same time. Okay.
So the left controller is up and down. If you bring that one up, you'll go up.
Ah. How do I look down though?
So you can bring it back down to go down.
So I'm gonna turn around and fly in the door. Maybe not. Well, this is. This is, Jennifer, you should try this one.
We're in the ocean now.
You should try this one. You give it a whirl.
Ready, Steve?
Yeah.
See, it's hard to figure out.
Yeah.
That's kind of fun though, isn't it?
It is a lot of fun.
Might have to get a little cheapy drone and learn to get comfortable flying it before I get an expensive camera drone, right?
Bought my granddaughter one for Christmas. I'm going to tell her to bring it over and let me check it out.
See what you learn you like to do at the museum?
I just don't want to go in the water here. Oh, I thought I saw something.
There it is.
There it is. Man, we were way up there. Okay.
You took your magic and took off.
Yeah, it's here with the ocean. It's hard to tell how high up you are.
Yeah, we're not going in the ocean. I'm not a strong swimmer.
My kids, if they were here, they would have flown in and all around and that would make me nervous if that were like a real drone and I saw it, you know, I'd be like, oh, here it goes.
Yeah, we're going in the water. Oh, we broke something.
Oh, there's that car crash. Oh my goodness. Wow.
Yeah, so this was a car that was in the Kia 5 tornado that hit Moore in 2013. And no one was in the car at the time. Thankfully, the owner was working at a hospital and was sheltering there. But the car got cost a couple hundred yards by the tornado and got completely destroyed.
And this is how they found it?
Yeah.
With this chair and everything in the back? Look at where this front door, the door panel is.
Yeah, that's honestly the strangest thing that it got.
I mean, it opened that lid like a tin can. Look at that.
Yeah.
Wow.
This is wild.
Yes, we determined this on it.
People don't cut themselves, but oh my gosh.
That is insane, Jennifer. And so these numbers were like, as they were checking them, is that what that's for? 848, we'll have to look that up. And since it came into our life today.
So this is a T-28 aircraft, and it was originally a Navy trainer plane that then got repurposed to fly into thunderstorms. And so they had to reinforce the metal on these wings and reinforce the windows. And in the engine, they had to put some grates over certain parts of the engine to keep any hailstones out. And so all of these things made the plane able to fly into thunderstorms. And we have a video here of one of the pilots doing that. And normally this was a two-seater plane, but because they were collecting a lot of data about hailstone growth in these clouds, they had to...
Look at back here on the wall.
There's a different page we have back there, as well as a library that you're welcome to look at.
Those are incredible.
Yeah, so some of these are photographs, some are just different depictions of the weather.
Northern Lights. Wow, that's gorgeous. It's the back end of
Just
it.
like you were shot area, it's random odds and ends.
Random odds and ends.
Yeah.
Yeah, you can tell all the damage on there.
Yeah.
Duct tape works.
Bubble wrap.
Do you feel safer? And what have we got going on over here?
Yeah, so basically you can see the mechanism on the left there that could like slide along these tracks here and move to different areas of the plot of land. And then these things were different tools that could be attached to the bottom of the device there and could like water or harvest crops. And so this just kind of shows how resources could be managed, how you can use technology to manage resources in a farm more efficiently. And this sort of just ties into the connections between meteorology and agriculture because the weather is, of course, very important for farming.
It looks hot, but it's not. It's really nice out.
Yeah.
I see red and I always think I don't want to go outside, but it's really nice out today. It's a good day to be outside.
What is the lifespan of this in the caretaking, or once it's there, it's good for?
So these sites have been up for about 30 years. It was first established in the 90s, but the instruments will break periodically and have to be fixed or replaced. I don't know exactly how often each instrument needs to be replaced. Probably on the order of a decade or two would be my guess. And a few things I forgot to mention is that there's a lightning rod, so that way a palmetto tower can be a target for lightning. That way it won't destroy the instruments. And there's also a solar panel and a radio antenna, so that way it can function off-grid.
That was my next question, was the probability of damage from a storm when you're trying to provide weather information or climate information.
Yeah, so I think one of these got hit by a tornado at one point and it did like get broken, so they had to replace it. So that has happened maybe another time too. But
I've seen them several places.
yeah.
But you said there's one in every county?
Yeah, and some counties have multiple. I think there's 120 total of these stations.
Oh, wow.
And what's this?
That is just a little
Looks like my calculator
little calculator.
for geometry when I was in school.
Yeah.
I don't think I'd know how to use it any better
Yeah, they
today.
just call it a handheld. But could you imagine, you're in World War II and you're like, hold on, let me get my pop-up and see what the weather is going on.
Yeah, I think they would refer to this before they got on the plane.
I hope so.
While flying.
Like,
I would hope so.
And then this device there is a theodolite, and that's how they would track a weather balloon before GPS.
So as far as they could see it.
Yeah. And so that's how you would get the winds, because the balloon is carried by the wind, so you can see how fast it's moving in the air, and that's how fast the wind's blowing.
Nice.
And then this is an augmented reality sandbox. And so basically there's a Kinect sensor that will shine light down on, or the projector shines light, and the Kinect sensor just detects the height of the sand. And then you can so here would be a mountain and this would be like water, and you can change the pattern to make like a boundary.
Ah.
Do that, so you could kind of figure out where the water would flow. And so you can also sometimes hold your hand up and it'll make rain, but that can be a little finicky sometimes. And yeah, you're welcome to play around with that as well if you'd like.
That is really interesting. Oh, I see.
Shimmery stuff is where,
The rain.
yeah.
oh,
Oh.
I was really waiting on water to drop. I was thinking it's going to make some water come out of here. That's what I was doing, because there's a green blinking light. So I was watching that light, and you're like, okay, but I see what you mean now. That
Yeah, they're like these little,
it looks like,
that's
yeah.
the rain, yeah.
Okay.
So this would represent a massive, like mountain range area, a whole land surface.
Yeah.
Yes. That's very interesting. Very interesting. We learned, like I said, I grew up in Florida, and because I grew up in Florida and there's the Everglades, and we had what was called the Energy Management Center, and it was right out on the water. And you study biology, you study weather, you study oceanography, you study the wetlands, you study the animals. I mean, they teach you everything because of NASA. So science and math and things like that and biology are very big things in Florida. Their schools, they teach you all this. When there was a launch of the shuttle, we would go outside and watch it in the sky. I mean, it was amazing growing up in Florida to have all of those opportunities.
It seems cool.
Mm-hmm.
And they would teach you stuff like this. Is this actual footage of the storm that took this car?
So I think this is a different tornado. This is just a loop of different storm chaser footage.
Oh, okay.
And if you wait long enough, it'll tell you which storm it is, but I don't know this one
Yeah.
in my head.
Look at this. In the center, it's like a heart.
Looks like a heart. It does. Look at that.
Yeah, it kind of does.
Sure does, Jennifer. Look at how it twisted up those tracks, though. That's crazy. I've seen it eat up asphalt, too, like across a road. Like,
Yeah.
the asphalt will just disappear in a section of road.
Yeah. Yeah. Here is we have a little like tornado display thing.
Oh, there's a cow up there.
Yes. So that's just an homage to the movie Twister where they caught we got cows. And there's also, so in the National Weather Center on the South Campus in Norman, there's a restaurant called the Flying Cow, just also in reference to the,
Oh, how fun.
so yeah, here you can see it spinning out.
Oh.
So there's the rotation associated with the tornado that kind of makes you see displayed here.
That's actually how I did. So when I worked out at Schriever Air Force Base, when I had to put the encryption for the video teleconference call, it was on a ticker tape, on a punch ticker tape. That's how the encryption came in.
Interesting.
That we actually fed into the T1, into the shelf. Had a shelf special just to take that tape.
Cool. And yeah, here's some more weather instruments. So like some anemometers for wind speed in the top shells, and then down there there's a hygrometer for humidity. And this is like just an early computer device. And then these devices can record the temperature and the wind speed. And so before they had digital recording, they would attach a thermometer or an anemometer to a little lever that would be attached to graph paper, and then the paper would slowly rotate and you could mark it down to see how things change over time. And this thermometer there, operated by a piece, this would be two different pieces of metal that would expand or contract differently with the change in temperature, and so it would like bend based on what the temperature was, and so that's kind of how that device would operate.
Interesting. Every year more people are killed by flash floods than lightning. It's difficult to judge the depth of water, especially at night. Almost 2/3 of the fatalities occurred in a vehicle, so don't drive into floodwater, unknown depth. The water becomes your steering wheel. Yeah, as little as 6 inches of rushing water may cause you to lose control or stall your engine. 1 to 2 feet of water, yes.
Did you see this piece about the Fahrenheit and the history behind it?
Which one?
Right here, 1724, Gabriel Fahrenheit.
Wow. I think I've heard that before. Very interesting. I think I learned that in one other museum I went to one time, but I don't remember where. Look at the key, Jennifer.
Do you have a model of the type of key that you likely would use?
Looks familiar when you're discovering electricity and stuff. Oh, I love those.
Those radiometer that.
Yeah,
Cool.
with the oil and the water,
Yeah, the Galileo thermometer there.
the Galileo thermometer, yeah.
Yeah, and so that just the different densities of the elements will rise and fall as the temperature changes. And then this is a sling psychrometer, and that's kind of fun, just in that there you have two thermometers, one that's a normal one and one that has a wet cotton ball attached to it, and you'll spin the device around a whole bunch of times, and the water will evaporate from the cotton, and as it does so, it'll cool off, and how much it cools off will tell you how humid the air is. So it's just kind of a neat way to determine the humidity.
Well, that would make a good science project.
There you go.
Yeah, and we also just have like some little gag weather instruments like the weather rock,
The rock.
and we have like a weather stick and stuff like that, where it's like if there's snow on the rock, it's snowing, if there's water on it, it's raining, and so on.
That's funny.
Theodolite.
Yes, that's another one of those that could also be used to track weather balloons.
Isn't that a crystal? Theodolite?
Might also be that, I'm not sure.
I'm thinking that's a crystal, Jennifer.
I don't know all of them, but I do have a crystal app. So
I'm thinking we're into magical stuff like crystals. Thanks for joining me on this episode of Adventures with Tyche. Today, we pushed the limits of our boundaries, increased our wisdom, and expanded our curiosity. Join me next episode as we continue taking epic quests to discover the unknown.